Have you ever just stared at a website and wondered, how in the world does this actually get made? I mean, from a simple blog to a massive shopping site, every single one of them starts as just a blank screen. Today, we're going to pull back the curtain and show you exactly how that magic trick works, starting from the very beginning. So this is the big question, right? How does that happen? It really does look like magic, but what it really is a conversation. To understand how a web page gets built, we first have to understand how we can talk to a computer in a language it actually gets. Okay, so before we can even dream of building a website, we have to get one thing straight about the machine that's sitting right in front of you. A computer? It's incredibly fast and powerful, sure, but it can't think for itself, not even a little bit. It needs a set of super specific instructions to do anything at all. And that, right there, is the whole secret of programming. It's not some kind of dark art. It's just writing a recipe. Seriously, you know how a chef needs exact measurements and steps to bake a perfect cake? Well, a computer needs that same level of detail to do anything. We're the chefs, and the code we write, that's our recipe. And when you look at how it works, it's actually super straightforward. There are no hidden, complicated steps. It's just this. A person writes the instructions, the code. The computer reads that code. The computer follows the instructions exactly as they're written. And then bam, something happens on the screen. It's a straight line from our idea to what you see. So this leads to a pretty big question, doesn't it? What language are we using to write these instructions? I mean, we can't just type in English and expect it to work. We need a special kind of language, one that acts like a perfect translator between our human ideas and the computer's circuits. And that's exactly where programming languages come into play. They are the bridge that connects us to the machine. Each one has its own vocabulary and its own grammar, its own set of rules that lets us communicate our instructions without any confusion. The best way to think about this is like a toolbox. You wouldn't use a hammer for every single job. For websites, HTML is kind of like the hammer. It's for building the main structure, the frame. CSS, that's your paintbrush. It handles all the design and color. And JavaScript, that's the power tools, adding all the cool interactive features. Now, there are lots of other languages for other jobs like Python or Java, but today we are zeroing in on that foundational hammer, HTML. Let me put it this way. Every single website you have ever visited, from Google to your favorite tiny blog, is built on a foundation of HTML. It is, quite literally, the skeleton that holds up the entire web. Now, before we go any further, we have to get one really important thing straight, because it trips a lot of people up. It is so important to understand this. HTML is not a programming language. It can't think, it can't do math, it can't make decisions. Its job is something else entirely. See, HTML is what's called a markup language, and its entire purpose in life is to take raw content, text, images, links, and just give it some structure. It tells the web browser things like, hey, this chunk of text is a main heading, or this part right here is a paragraph, or make this thing a clickable link. It just defines the what and the where of all the content. This analogy just sums it up perfectly. Think of HTML as the architectural blueprint for a house. It defines the foundation, the walls, where the rooms and doors go, the core structure. But it has absolutely no say in the paint colors, the wallpaper, or the furniture. That's a totally different job for a totally different tool. So, how does HTML actually do this? How does it create the structure? Well, it uses a set of really simple but incredibly powerful building blocks that we call tags. Okay, so take a look at this. Every piece of content in HTML is wrapped in what's called an element, and it usually has three simple parts. First, you've got an opening tag, like this P, which basically says, hey, a paragraph is starting right here. Then you have the actual content, the words. And finally, you have a closing tag, which looks almost the same but has that /P. That just says, okay, the paragraph ends here. And that's really it. You can honestly think of these tags like different kinds of Lego bricks. You've got bricks for headings, bricks for paragraphs, special bricks for images, and bricks for links. By combining all these different types of tags, you start to assemble the different parts of a web page piece by piece. Each tag just tells the browser what kind of content it's looking at. Now, these little elements generally behave in one of two ways. You've got your block elements, like headings and paragraphs. These guys are kind of greedy. They take up the entire width of the page and always start on a new line. Then you have inline elements, like links or images. They're a lot more polite. They only take up as much space as they absolutely need, and they're happy to sit right next to each other on the same.
All right, so we've talked about the theory, we've looked at the individual Lego bricks. Now let's put it all together and see what the actual blueprint for a simple web page looks like.
Now, this might look a little technical at first glance, but it's really, really simple when you break it down. This is the basic anatomy of almost every single web page out there. You have the main HTML tag that wraps everything. And inside that, there are two key parts. The head, which is kind of like the brain. It holds background info for the browser, like the page title. And then there's the body, and that's where all the good stuff goes. All the content you actually see on the page. It's just a simple nested structure. And finally, just to really hammer this point home, it's so important to remember what HTML cannot do. Because it's a markup language, not a programming language, it has zero logic. It can't do math, it can't make an if-then decision, it can't store information, and it can't create all the slick dynamic interactivity we're used to seeing. Its one and only job is structure. That's it. So while every website absolutely needs this HTML skeleton just to exist, a skeleton by itself is, well, pretty boring and bare. Which leads us to our final and most interesting question. If HTML gives a website its bones, then what gives it its skin? You know, the style, the design, the colors. And what gives it its brain? The power to actually think and interact? Well, that's a story for another time.